Alright, welcome to another exciting video. Of course, you can see we are on question number 3 under simple stresses and strain. Now, the question on the board says a hydraulic press exerts a total load of 3.5 meganewton. This load is carried by 2 steel rods. Of course, you can see that the load of 3.5 meganewton is carried by 2 steel rods supporting the upper head of the press. If the safe stress is 85 megapascal and Young modulus is equal to 210 kilonewton per millimeter square, we are asked to find the diameter of the rods and the extension in each rod in a length of what? 2.5 meter. So first we are going to be bringing out our data before we solve. So our data is given. Now, what do we have? We have a total load of 3.5 meganewton that is carried by 2 steel rods. So P, which is our load, will be equal to what? 3.5 meganewton. This is our P. Next, what do we have? We have a safe stress of 85 megapascal. So our stress, sigma, will be equal to 85 megapascal, which is 85 newton per millimeter square. Next, what do we have? We have our Young modulus, E, to be equal to 210 kilonewton per millimeter square. And lastly, we have a length of 2.5 meter. Our length is equal to 2.5 meter. This is 2.5 meter. These are our parameters. So we are going to be looking for first the diameter of the rods. Now, in order to look for the diameter of the rod, first thing first, we are going to be looking for our area. Of course, our area A is nothing but what? Pi all over 4 multiplied by what? Multiplied by d square. Now, pi all over 4 is nothing but what? It's nothing but 0.7854. So this will be equal to 0.7854 d square. Just press pi all over 4 on your calculator and you are going to have what I just have here. Now, if you look at this question, you will notice something. We are given a total load of 3.5 meganewton and the load is carried by 2 steel rods. So if I'm to find the diameter on each rod, I'll have to divide this load by 2 because the load is carried by 2 steel rods. So I'm asked to find the diameter of the rods. So I'm going to be finding the diameter of each rod. So first thing first, I'm going to say P1 be the load on one rod. So if P1 be the load on one rod, P1 will be equal to what? It will be equal to P all over 2 in order to get the load acting on each rod. So P1 will be equal to 3.5 meganewton all over 2. So I'll be having what? P1 will be equal to 1.75 meganewton. So our P1 will be equal to 1.75. P1 will be equal to 1.75 meganewton. So this is our P1. Now we can go ahead and find the diameter of this rod. How do we do that? We know that stress is equal to what? It's equal to force all over cross-sectional area. And here we have our force, that is our load, which is acting on the rod. We also have our area here, which is 0.7854 d square. So all we just have to do is to substitute. So let's do that. We have sigma to be equal to load all over what? All over area. So our sigma now from this question is nothing but what? Is nothing but 85 newton per millimeter square. So I'm going to be putting 85 here. This will be equal to what? This will be equal to our load. And of course, we have calculated our load to be 1.75 meganewton, which is the same thing as what? Which is the same thing as 1.75 newton per millimeter square if converted. All over what? All over our area our area is nothing but 0.7854. So we have 0.7854 d squared. So all we just have to do is to find the value for d, which will be our diameter of the rod. So let's do that. We are going to be first cross multiplying. If we cross multiply, we are going to be having 85 multiplied by 0.7854 d squared. This will be equal to 1.75. So this is what we have. If we divide both sides by the coefficient of d squared, we are going to be having 85 multiplied by 0.7854 all over what? 85 multiplied by 0.7854. So this is what we have. So of course, you agree with me that this can go with this, and we left with what? D squared, which will be equal to 1.75 all over 85 times 0.7854. Now, I will just bring this down. I'm going to be having 1.75 all over what? All over 85 times 0.7854. What do I do next? Of course, I can take the square root of both sides in order to make d the subject. If I do that, you agree with me that square root will go with square. So I'm going to be having another square root here. So d will be equal to, if you press this in your calculator, d will be not equal to nothing but 162 millimeter. So our diameter here will be equal to 162 millimeters. Divide this and take the square root. You are going to be having 162 millimeters. So this here is the diameter of the rod. So next, we are going to be looking for the extension in each rod in a length of 2.5 meters. Like I said, we are going to be looking for the extension in each rod in a length of what? 2.5 meters. Now, how do we do this? We know that our Young modulus is equal to sigma all over what? All over strain, which is of course stress all over strain. So from that relation, we are going to be looking for a formula that we can use to find the extension. Now, Young modulus E is equal to sigma, of course, and we know that our sigma is what? It's equal to force all over area. So we can say it's equal to P all over A. And our strain is what? It's equal to what? Change in length all over original length, which is what? The L all over what? All over L. This will be nothing but P multiplied by L all over what? All over A multiplied by the L. So this is what we have. So our Young modulus is equal to force multiplied by what? Length all over area multiplied by what? Change in length. But we know that force all over area is equal to sigma. So instead of force over area, we can just use sigma here. So if we do that, our E, which is 210 kilonewton, which is nothing but 10 to the power of 3, will be equal to sigma multiplied by L all over what? All over the L. So this is what we have. So next, what do? We are going to be substituting for sigma. We are going to be substituting for our length. So let's do that. This will be equal to 210 times 10 to the power of 3 will be equal to, our sigma is nothing but what? 85 Newton per millimeter square. So we have 85 Newton per millimeter square here. It will be multiplying a length of 2.5 meters. Converting 2.5 meters to meter is nothing but 2.5 times 10 to the power of 3. So we have 2.5 times 10 to the power of 3. This will be all over our change in length, of course, which is what we are looking for. So this is what? Our change in length. So next, I'm just going to be cross multiplying in order to get my value of change in length. So if I cross multiply, I'm going to be having 210 times 10 to the power of 3 multiplied by change in length. This will be equal to 85 times 2.5 times 10 to the power of 3. Next, I'm going to be dividing both sides by the coefficient of change in length. If I do that, This will be 210 times 10 to the power of 3 all over 210 times 10 to the power of 3. Of course, this will go with this, and my change in length will be equal to, of course, just multiply these two and then do your division. You are going to be having nothing but 1.012 millimeter as your change in length. So our change in length will be 1.012 millimeter. So this is the change in length or the extension in each rod in the length of what? 2.5 meter. I hope you comprehend and understand this solving correctly. Stay tuned for more videos, and thanks for watching.